In this video we're going to look at oxidation states. Oxidation states are numbers that are assigned to elements in a compound to show if electrons have been lost or gained when that compound has been formed. So just a reminder that oxidation is loss of electrons and reduction is gain of electrons, and we can remember that by remembering oil rig. To work out oxidation states, it's useful to think about elements with their GCSE electron structure and to think about the number of electrons in their outside shell and whether they are more likely to lose or gain electrons. So for example, group 1 elements have got 1 electron in their outside shell and therefore lose that electron to become a +1 oxidation state. Group 7 elements have got 7 electrons in their outside shell and usually just gain 1 electron to become -1 oxidation state, although chlorine can become positive, as can bromine and iodine. However, fluorine is always -1. Oxygen is usually -2, except when it's bonded to fluorine or when it's bonded in hydrogen peroxide, which is H2O2. When it's in a peroxide, oxygen is -1, and that means that the hydrogen is +1. Group 2 metals are always +2. Hydrogen is usually +1, except when it's bonded in a metal and it's called a metal hydride. So this example here is called lithium hydride. And lithium hydride would be where lithium is +1, hydrogen becomes -1. So these are the general oxidation state rules. There are 1 or 2 exceptions, so just be careful of those. It's important to point out that the oxidation state on an element is 0. So for example, in oxygen O2 the oxidation state is 0. Also for simple ions, so this is the nitrate ion, the sum of the oxidation states needs to add up to the charge on the ion. So the charge on this ion is -1. So the oxidation state must add up to -1. So we know oxygen is -2, meaning that we've got 3 lots of -2 giving -6. We've got negative there, -1 there. So overall the nitrogen has got to be +5, because +5 add -6 equals -1. So the sum of the oxidation states of the elements in a simple ion needs to equal the charge on that ion. So that's that for the nitrate ion. So some useful ions to know are the sulfate ion, which is SO4 2-, nitrate NO3-, carbonate CO3 2-, and the hydroxide ion OH-. Okay, so oxidation states show if electrons have been lost or gained when a compound is formed. Just some key tips are to use the periodic table to help you work out whether or not electrons are being gained or lost. Where you're unsure, check the electronegativity of an element. The more electronegative an element is, it will be the negative one in the compound. This is why fluorine is always -1, because it is the most electronegative element. As you go up the periodic table, electronegativity increases, and as you go from left to right, electronegativity also increases.